All right, can we do that one? I think you can do that one easily, right? Remember that stuff? So what do we do?
Get rid of the parentheses.
Yeah, this just distributes through, huh? Whenever something's in front of a parenthesis, it just multiplies through. We good? So 7x plus 14, right? And now, what about that minus sign in front of the parentheses?
It separates both.
What's that?
It separates both parentheses.
It's a what?
It separates both parentheses.
I still not. It's a Briggsmore parenthesis.
No, it separates. Wow.
Oh, it separates. Sorry, I'm really twisting the words around.
Yeah.
It separates, yeah. So that minus sign is going to go boom, boom, like that.
Oh, yeah.
Just like anything up against a parenthesis. It's really a minus 1, if that helps you. Right? Anything up against a parenthesis is going to distribute. Minus 3x plus 3. Does that make sense what we happened there? That negative 1 multiplied the 3x and multiplied the negative 3. Now what do we do?
Then we group the similar terms.
Yeah. What are they called? Like terms, yeah.
Like
7x minus 3x.
10x. I mean 4x.
4x. And 14 plus 3?
Plus 7.
17. All is well? Remember all that? Questions I can answer? So as I'm going over, what are there, like 20, some fractions there. So same kind of thing. Distribute through those parentheses. Maybe I can make it bigger. 1/3, 12m. So number 2. 12m plus 12. Minus parenthesis m minus 5. Yeah. I don't want to go too slow or too fast. So that 1/3 is gonna multiply in there, huh? So it's really just going to divide those things by 3, right? So 12 divided by 3, 12m divided by 3 is 4m, and 12 divided by 3 is 4. Is that good? And then that minus sign, same thing as a minute ago. It's a funny looking 4 there. Minus m plus 5.
Yes.
All is well. 4m minus m.
3m.
3m, and 4 plus 5. 9. Good? Easy? All right. So I want you to solve. This one's a little different. Do you see why? Because it has an equal sign. So it has a left side and a right side. The equal sign is kind of like a wall of separation. See how that's different? Look back at number 2. See, there was no equal sign anywhere in number 2. There wasn't a left side and a right side. See the difference, what I'm talking about? So number 3 has an equal sign, left side, right side. So they want you to get y alone. They say what, the bottom thing says, what is y? Multiple choice final would say, some answers for y. Like y is 2, y is 3, y is negative 5, whatever. So we'll start distributing through the parentheses. Boom and a boom. So we'll get 8y plus 3y minus 18. Boom and boom. And we'll get 5y plus 5 minus 4. Good. Anything up against the wall of a parenthesis distributes in, right? Multiplying all the things inside. So now 8y and 3y is 11y. 5 minus 4 is 1. You good there? Now, what do we do when we have y's or x's or whatever, letters on opposite sides? Yes, usually we subtract the lower one from both sides. So the lower one is the 5y, right? I'm not worried about the minus 18 or the 1 right now. I'm just focused on the 2 y's. So we subtract the lower one. So that would be the minus 5y from both sides like that. And this will be 6y. And that's 1. And now we got to get y. Y said I won't be alone. So what do we got to do to get y alone? Add that 18, right? And that cancels. And so 6y is 19. Last step to get y alone. Divide. Last step is always divide, huh? There it is. 19/6. There it is. 19/6. We good? Questions I can answer on that one? All right. Okay. So try that one. fractions.
Yeah, get rid of fractions.
You got to get rid of fractions, exactly. So when you have fractions, multiply by the LCD, the common denominator. What's the common denominator? Yeah, you got to use the 3 and the 5. They're both denominators, huh? And 3 times 5, 15 is the LCD. Is that making sense? So what I'm saying is then, you got to come back here and you got to multiply by, let me put it here, 15 on him. Whoops, I can't make that 15 very well.
26/3.
Oh, boy. And 15 there.
X minus 5.
Is that right? And 3 goes into 15. How many times? 5 times. So that'll be 5x. And 5 goes into 15. 3 times, and we get 3x. Is that good? Both sides? Bring down the 1 and the 3. No?
I had to do the
Natalia?
I thought you had to do the whole.
Excellent.
Yeah.
I'm messing up. Does everybody see that? I'm doing what I've seen a lot of students do over the years.
Like what?
Right? What am I doing wrong? Is
Yeah, everything.
top and the bottom.
that helpful teaching? Like purposely doing the wrong thing like that?
Well, it's
They've
not
all,
gonna
no,
be
not top
big,
and bottom. No. They've all got to get a 15, huh?
Straight.
Is that making sense? Are we good? So that's now correct. So we have to multiply all the way through by 15 like that. So minus 15 plus, what happens with the 3 and the 15 over there?
Multiplies
They multiply.
with 45.
Like that.
X minus 1.
Is that good? Everybody see that? So multiply all the way through when you do the fraction. Can you take it from there? So what do we do when we have x on opposite sides? We get rid of the lower one. Right, get rid of the 3x on both sides. And now x wants to be alone, so add the 15 on both sides. 2x is 60. Last step. Divide by 2. X is 30. Good? So you okay with that first step with fractions? Feel like you know what to do with those? You'll be okay on the test? Something like that? Multiplying through by the common denominator. So when you have two denominators, you multiply those together. 3 times 5 is 15. And then you multiply the 15 to everybody. Right? Here's the first step. So we have this problem. Common denominator is 18. So I multiply through all of them by 18. I don't know if this one is readable here. Is that good? So multiply through every term by 18. And then what? Divide by any denominators. Anything under the bar cancels, huh? So I go 6 into 18. 3 times. Multiply what's left over. 3 times 5. 15x. Minus. Is that making sense? So you cross cancel. Multiply what's left over. So 6 went into 18. 6 went into 18 3 times. 3 times 5, 15x. Right, good. Keep going. 2 times 18, 30. Now, hey, why don't I go 2 goes into 18 9 times? That's wrong.
It's wrong.
Why don't I do that? Yeah, because that 2's not under a bar, huh? It's only things under the bar that cancel with things above, right? It's cross canceling, bottom to top, right? So that 2 is just going to multiply the 18.
That's 26.
You put it back. What was it? It was 2, and I multiplied by 18. So it is 36. I actually wrote the right answer, didn't I?
So this is 90.
It's going to be 36. Is that good? What? And then what happens with the 1/3 times 18? Try that one. Make sure you can get that one.
That give us 6x.
3 goes into 18. 6 times 6x. We good there?
Okay.
18 cancels 18. 5x.
5x.
6 goes into 18. 3 times.
3 times.
Is that good? So isn't that nice? We get rid of all the fractions, huh? So we always get those fractions out of there in the first step. So take it from there now. Get x alone. So 15x and 6x. X is on the same side, just add and subtract, huh? Now we have x's on opposite sides. So what do we always do? Get rid of the lowest one. Subtract 5x from both sides. So what is that? 16x. And now we just get x alone, add 36. This used to be harder for y'all,
So that's 13.
but it's easy for you now, right? Divide by that 16, last step.
That's 1.
And we can't reduce that, huh? That's just it. 39/16? Nothing, you can try calculating, nothing goes into 39, and 3 is all that goes into 39. 3 times 13, nothing goes into 16 but a bunch of 2's and 4's. So that's it right there. Is that good? You feel like you're okay with those fraction ones? Fraction ones are important. They cause trouble. So maybe I can circle back and grab a new one in a bit.
Yeah, one more.
Let me move ahead. I want to try to get through everything, but if I have time when I finish, I'll come back and I can ask it to generate a new one. Good? No questions? Good with all that? Common denominator cancel? The governor of state A, one of these word problems, the governor of state A earns $54,885 more than the governor of state B. The total of their salaries is $292,705. Find the salaries of each. Let me write that out. A earns how much more? 54,885.
885. 8 plus
54. I didn't write that very well. More than B. Total of their salaries is what? 298,705. So find each. So there we go. Okay, so let me help a bit. What does it say about A? A earns, A equals. B add 54,885. Does that make sense what it says?
So this is A.
Excuse me. A is earning this much more than B, so it's added to B, huh?
Yeah.
It's more than B.
So
Does that make sense? What I'm writing there? A's salary is whatever B's salary is. Add 54 54,885, right? Because A is more. Does that make sense on that? So that's A. That's A's salary. The general game plan, it says the total of their salaries. So I'm going to go A plus B is 298,705. That's what they're saying with that one, huh? The total of their salaries is 298,705.
Yep. And then we subtract what is more.
So is that good to there so far? Does everybody agree with those two statements? I basically kind of directly handled the two sentences, huh? The first sentence, A earns 54,885 more than B. So A is B add 54,885. That's what that first sentence is saying. Second one, total of the two, A and B, add up to equal the 298 number, right? Now, what do you do when you've got two letters like this? Yeah, plug it in, exactly. Remember that? So I just take this right here, and I plug it in right there for A. Do you see why? Because that's what A equals. So I put it right there because that's what it says A is. A is B plus 54,885. So I can replace A with B plus 54,885 because that's what A is the same as, huh? Does that make sense? So do that. Plug that in. Then you'll have an equation with just B. That's what we need. We need just one letter, huh? And then you can solve for B. Take it from... All right, so here in the A spot, it's going to be B plus 54,885 plus B is 298,705. We get to there so far? Is that making sense? So all of this was the plug-in from A. Everybody see that? Right? In the place of A, I put B. I put what A is. A is B plus 54,000. Now I have an equation that only has B, so I can solve just like you would for an X or something, huh? So how am I going to solve that equation? What do I do with the B plus the B? What is it?
Is it combined?
Combined like terms, huh? Yeah, it's 1B and 1B, isn't it? It's 2B plus 54,885 equals 298,705. Is that making sense? See how the B and the B made 2B there? We go to a fresh screen. I'm running out of room there. That's okay. So it's 2B plus, what is it? 54,885 equals 298,705. All right, and how do we solve for B? What do we do now? B's saying, I want to be alone. Yeah, subtract the 54,885. Boom, so bring it down. Somebody have a calculator? 243. I don't know. I'll lose it from there.
820.
820, thank you. 820. And then last step? Divide by 2, huh? So B equals 120. 910. Thank you. So there's B. That's B's salary. Isn't that good? That's B's salary. Did y'all get that? Now, how do we get A's salary?
Add 54,800.
Yeah, back over here. Exactly. See what it says? A is B, add the 54,885, huh? So A's salary is B, add the 54,885. So I take that, put it in there for B, and so A will be the 121, 910, add 54,885. So A will be 76, 795? Thank you. 795. We got it. How are we doing? That's the big ugly numbers. We okay with all that? Questions I can answer? Look, you could get that on the final on Tuesday. We go back here. So see how we did in the beginning? We just took those two sentences directly, right? 55,001 A is more than B. And then the total is 298, and I plugged in. Questions? How we doing? Are we good? Are we feeling alert? End of semester's hard, huh? Not long till Christmas break. One more week, and then you got a couple weeks off. All right. I just want you to plug everything in and work out the numbers. So give it a go. Yeah, let's plug stuff in. So A is 45, so that goes over here. H, I don't know. Capital B is 4, little b is 5. So it's 45 plus a half H times 9. Good to there?
Yeah.
Now, what'd y'all do at this point? There's a few different things you could do. Alfred? Yeah, I always think it's good to get rid of the fractions, as soon as we can. So what's going to get rid of that half? Multiply by 2, huh? Multiply by 2. Now, so I'm going to multiply by 2 here and 2 there, and it cancels that, doesn't it? Does that make sense? So we get 90 equals H times 9. Is that good?
What happened with the 9? They need to be multiplied by 2?
Good question. Yeah, so should I multiply the other ones by 2? No, because it's one term. This is where, like, if it was plus the 9, then he would also get a 2, because that would be a separate term. Does that make sense? Yeah, right. If there's no pluses or minuses between them, there's no separation. That's right. This is all one term, so it just gets 1, 2. Yeah, pluses or minuses are the things that separate. They're the separators in algebra.
Couldn't you just divide by 9 at the beginning?
You could. That's another good way. Just divide by 9 right in the beginning, and yeah, you can. But then you're still going to have to multiply by the 2 to get rid of that half. But yeah, you could do that too. So I'm going to divide by the 9 now at the end here. Divide by 9. Boom. H is 10. The height is 10. We good there? Questions on that? Okay, there we go. So try that when we want to solve for x and y. This is a 3 here. They want us to solve for x and y. The plan is to make opposites. So when you do it, you have to multiply through by 2 all the way. You can't just do part of an equation. You got to do the whole thing. Why am I doing that? To make them opposites, right? To make that minus 8y.
This is the adding method.
Yeah, called the addition method. That's right. It's also called elimination. It goes by both names. Yeah, right. Exactly. Can you take it from there? Let's see it. So we add these up. So I'm going to bring these down now. This will be 10x minus 8y is 36, and bring this one down. 3x plus 8y is 3. And then add them up, huh? Add them up. 10x and 3x is 13x. These cancel. 39. Whoops, kind of funny looking 39 there. Good? Does everybody see what happened? So this is called the addition method where you add them, right? So I just made these guys opposites. And then just add straight up and down. 10 and 3, minus 8 and 8, 36 and 3. Last step to get x alone. Divide by 13. And x is 3. So we got x. Now we come on up and plug in for y. Bring it up here. plug in x equals 3. Where? Anywhere you want. Doesn't really matter at all. It'll work everywhere. So I'll bring this one over maybe, the first one. I usually just grab the first one. 5x minus 4y is 18. Plug in, grab that 3 and plug it in right there for x. So we get 5 times 3 minus 4y is 18. What's that? 15 minus 4y is 18. And how, no, here's y saying I want to be alone. Yeah, subtract 15 on both sides. Gonzo. Minus 4y is 3. Last step. Divide by minus 4. Is that right? Oh, it was weird. It's a fraction. Okay. So y is minus 3/4, isn't it? Came out to be a fraction. I didn't expect that. There we go. Is that good? Questions on that? There it is. So solve that however you want. There's a couple of methods. It doesn't matter.
This is substitution.
Yeah, I think this one would be nice just plugging. See that bottom one's already got x alone?
Yeah.
So it'd be pretty easy just to plug it into the top one, huh? See, the last one, x and y were not alone. See how it began? X and y were all together. No, we never had x alone or y alone, huh? But this one, we already have x alone in that bottom equation. So you could plug that in for x in the top equation. Does that make sense? That'd be easy. Okay, so x is 3y minus 2. I'm going to plug that in for x right there, huh? That good? So what do we get? We get, so bringing that down, this will become 3. And then the x is 3y minus 2 plus 2y is 38. Does that make sense so far? So I plug that in, and then we distribute. Be 9y minus 6 plus 2y is 38. 9y and 2y. Those are on the same side, huh? So I know you can't go minus 2y. Why not? Because they're on the same. Things on the same side, we just add them together, subtract. We only do the minus 2y kind of thing when they're on opposite sides of the equal sign, huh? Is that good? So we just combine together. 9y and 2y is 11y, isn't it? Get to here, and then we add 6. And so we get these canceled. 11y is 44. Last step to get y alone, divide by 11. So y is 4. And so now, come up here, and I'm going to plug in y equals 4. Now, the easiest place to plug, since what do you want now? You want x, huh? We've already got y. We're looking to get x. So the easiest place is going to be where x is already alone, right there. X equals 3y minus 2. Grab the 4. So 12 minus 2, x is 10. X is 10. Well, so they want you to type it in usually as an ordered pair. X, y, like that with a comma, with the parentheses and the comma stuff. 10 comma 4.
Oh, we have to the
Parentheses with the comma. It's called ordered pair. Yeah.
Oh, I forgot about that.
Yeah. It won't be a problem on the test, on the actual final, because it's be multiple choice. You'll just grab it. But yeah, on the practice final, it'll harass you if you don't put it like that. It'll make you do it again. But extra practice is always good. Okay, one more of these. There we go. Try that one.
I multiply to cancel.
Okay, so I'm going to get the y alone. So I'm going to grab that 4.
Oh, what you're saying is both.
Jump it over.
Then it's no solution.
So there it is. Y is alone. So remember, whenever you have x or y alone in an equation, you can then plug it into the other equation. So y is alone there. So in the second equation, so I can grab it right here and plug it in for y right there. So this one will become what will it become? It'll become, bring it over here, 6x plus 3, and then minus 2x minus 4 equals 5. Does that make sense what happened there? So in the place of y, 6x plus 3, y, 6x plus 3, and then y, negative 2x minus 4 equals 5. Everybody see what I did there? Just pop it. So that's the same thing we did in the last problem. You can get, an x or a y alone. Right? That's what we did back here, right? X was alone. Plug it into the other equation, huh? So same thing. Okay, so now we got to work this out. What do we got? 6x plus, that 3 is going to distribute. Minus 6x minus 12 is 5. 6x minus 6x, it's gone. Minus 12 equals 5. I didn't know. No solution. That's not true. The letters have all vanished. How could we solve for x or y? They're just gone. And what's left is not true. No solution. By the way, what if the letters all leave and you get 0 equals 0? That means infinite. Infinite. So that might be the one I put on the test. Or what if you get like 10 equals 10? That's still infinite. So, because why? Because it's a true statement. So whenever you have truth, you have answers. This one's a false statement. So if all the letters leave and what's left is false, that's no solution. What's left is true, that's infinite solutions. So you could put that on your full sheet of notes for the final exam on Tuesday. Be good to have that for Tuesday's final. Is that making sense? Questions on that one? All right, we better get. So let me make the equation a little bigger here. 4x plus 3y is 24. So how do we graph?
We resolve for y.
Yeah, good. You remember what Manuel said? Get y alone first, huh? So first step, get y alone. Yes. So can you get y alone there? First get y alone in order to graph. That's your first step. So get y alone then. All right, so we got to get y alone.
Okay.
Grab that 4x, jump it over.
Boom.
So 3. What happens? It becomes minus 4x, right? Now notice I put the x in the front. You don't have to, but that's the way we usually did it. Might look more familiar to you that way. And then next one, we're going to divide through by 3. Boom. So what do we got? Y equals minus 4/3 x plus 8. Good to there? We all happy about that? Now, how do we graph? Yeah, we start at the number not next to x. The other number, the fraction next to x, is a slope. That's our rise and our run. First start at 8. It's right up there, huh? It's up 8 in the middle. Remember that up at 8 there? Is that good? And then where do we go from there? You rise negative 4. How do you rise negative 4? Down 4. 1, 2, 3, 4. And then run. Go sideways 3. 1, 2, 3. So there's the second dot. There's our 2 dots. And then connect the dots. And you got your line. Is that coming back? Down 4 over 3. And this one's up at 8. Right? So the way to graph lines, get y alone. Whatever the number not next to x, that's where you start. Your first dot at 8. It's always in the middle, huh? A first dot is always in the middle. Positive is up, negative is down. Up 8, and then down 4 over 3, the slope. Connect the 2 dots.
And we need to put our pair, what is it? X is A, and,
Oh, we don't have to just click on the graph in those two spots, it'll make the line. That's all you gotta
we don't
do.
need the pair.
Nope, don't need any order pairs. They just want the picture. You good?
Y2 minus Y1, or?
Yes, slope equals what? Now I had my own little method here, which I think is a little easier than what the show me example button shows. So slope equals y minus blank over x minus blank. Remember, it's almost like, remember the slope formula? y1, y2, x, it's almost like that, but it's plain y, plain x with blanks at the back. So really good. So right now, you could be, let me make a suggestion. It would be wise of you, you'd be a wise student who would right now be saying, you know what, I'm going to have my study sheet for the final, because you get a full sheet, right? Put anything you want on it. All the things that we're running into, anytime you need a formula, write it right now. Take out a piece of paper with you right now, on a separate paper, your study sheet, and I would write, for finding slope equals y minus blank over x minus blank, you know?
We use a front back.
Yeah, front and back. Front and back, full sheet of notes. What should go on there? Anything you need as you go over the practice final, right? I'm assuming it goes beyond the question that you're going to do the practice final again later, right? You need to do that thing a couple of times. Math finals are, really take practice. So do the thing a couple of times or suffer on Tuesday. It's really true. You need to practice. You need to practice. A little healthy fear is a good thing in math. To get plug the stuff in. Yeah, this is an x value, and this is a y, huh? So put the and this is a slope. So put the slope right. M means, I don't know what M stands for, but it's the slope. So 3 over 2 equals y minus x minus, and this is the x value, goes behind x. This is the y, but don't forget the negative there. See the double negative action? See what I mean? Yeah. There's a minus built right into the formula, and the y value is also negative, double negative, positive. Watch out for that. So is everybody good to there? See what we're doing? So what do we do next?
We cross multiply?
Good. Cross multiply, huh? Remember when you have a fraction each side? Diagonal, diagonal? Right? So that's 3x minus 9, 2, y plus 5. See how I made a plus there? 2 negatives plus. Is that good to there? Let's distribute. So we get 3x minus 27, distribute. 2y plus 10. I'll bring it up here. Where are we at? Okay, so 3x minus 27. 2y plus 10. We get to there? How are we doing? What do we have to do next?
We resolve for y?
Yeah, that's a good question. So yeah, here's what, if you look at the multiple choice, it'll help to have the multiple choice. You'll see if they want x, then y, then numbers. You'll see all the answers have x, y numbers. So I've got to take my thing and make it x's, y's, and numbers. So this is basically the answer. It's just not organized.
Like we switch them.
Yeah. So we have to have x's first. We've already got that. No problem there. We got to have y's next, huh? So grab that 2y and jump it this way. And then I don't want the minus 27. The numbers go on the right side, so jump that one the other way. Does that make sense? Can you do that? That swap-a-roo there?
Yes.
And what do you get? 3x minus 2y. That minus 27 jumps over, becomes a positive 27. And so that's 3x minus 2y, 37. There we go. We good? All is well? You don't look overly happy about that one.
Forgot about it, to be honest.
Yeah, we'll do one more that's even a little harder. Is that good news? So I want to make sure this one's good before we move on. So when we have slope and a point, you write slope formula, y minus blank, x minus blank. Yeah, like Shelby did, write some notes for that. And then cross multiply, and then organize it, x's, y's, numbers. So have something on your sheet for yourself. Okay, so I'm going to try one that's only one step harder. On the next one, they won't give me the slope, but they'll give me 4 numbers. So I get my own slope, and then I do all this. It's a lot of work. You ready? This is basically a Math 63 question. In fact, I just put a problem like this on the Math 63 final, which I'll give my 63 students on Monday. Just about like this. So it's the same thing. So you'll see it again if you go into the 63. I'll make it easier. So, all right, so same kind of thing. They want the equation. In the end, they're going to say, find the equation. You know, like AX plus BY is C. They want the equation AX plus BY is C. So, the first thing you got to do is what?
Get a formula.
Get the slope. Yeah. And what? Now this, we're going to do y2 minus y1 over x2. This is where you plug all 4 numbers in, not the slope formula that I put up on the board. We'll use that in a minute. That one's coming. But first, we got to get our own slope by using all 4 numbers. Do you remember this? Calculating a slope using all 4 numbers? Do you see how much there is to remember? You don't want to start studying for this the night before. Math finals are serious business. They just are. It would be academic suicide to try to just study the night before. You might as well just come to class and turn in the towel. It's ball game over. I'm trying to scare you for your good. With truth. I'm trying to scare you with truth for your good. That's not bad. That's appropriate, healthy fear, like not playing on the freeway when you're young and chasing your ball on the freeway. It's wise to be afraid of the freeway. It's wise to be afraid of math finals. So I'd work on this every day between now and Tuesday. Just every day do about an hour of the practice final. Just do a couple problems, and you'll learn it way better. Math science is learned in little bites, way better than one big bite the day before. So little bits, little bits.
You get -4.
So can you get that?
When we get a slope, do we leave it as a fraction?
Yeah, leave it as a fraction. This will be x1, y1, x2, y2, right? Slope is going to equal. Be careful with your signs. Careful with your signs. Make your signs big and bold. y2, -6, minus y1, negative. Do the double negative thing there?
Yeah.
There's a minuses from the formula plus the minuses we plug in over x2 minus x1. We good there? So that slope is -6 plus 2, right? Double negative is positive. 1 plus 1, what's that? -4/2. Yeah, no, go ahead and reduce it. Sorry, Karina, I wasn't telling the whole truth.
Okay.
Go ahead and reduce it. I didn't know it was completely reducible like that. Yeah, just go ahead and reduce it all the way down. -2 is the slope. We good? That's about half the problem.
And when we have the slope, we need to move.
Now we do all the stuff we did in the last problem. Now that we have a slope. You see, on the last problem, let me show you. They just gave me a slope right in the beginning. See that? They just handed me a slope. So now I had to get my own slope, -2. Now use that slope. So that's all part 1. We good? Now do part 2. Part 2, where you write the slope formula again, but now the new way. Y minus blank over x minus blank. Like it's on the sideboard over there, huh? Seeing what I'm saying? We good? Are we waiting? Anything I can answer? Is this making sense? We have the slope. Now, plug in the slope and then use one of the points. Which one? Doesn't matter. How about the first one? Just grab that one. Or the other one. It doesn't matter. So plug in the slope and plug in the point, right? Coming back over here, the slope. What is the slope? -2.
X minus. And we take one of the pairs.
One of the pairs. I usually just grab the first one. Yeah, you're totally right, though. Yeah. So I'm going to usually grab that first pair, but you could grab the second. It'll work either way. But it's making some sense? So -1 is the x. -2 is the y. See that? All right, take it from there. Your next step is to cross multiply, isn't it?
Mm-hmm.
How are you going to cross multiply? What do you do with that -2 over on the left side? Over 1, diagonal, diagonal, right? Make it look like a fraction. Over 1, diagonal, diagonal. Put this over 1, diagonal, diagonal. Take it from there. So let's keep going. -2, x plus 1, 1, y plus 2. Everybody see that? Those double negatives become positive. Right? Distribute. -2x minus 2. Distribute. Y plus 2. Now, final thing. Remember what we got to do? We got to get x's first, then y's, then numbers. That's how they want the answer. So I got to reorder it, right? We good? Okay, what if I bring it up here? So we have -2x minus 2 is y plus 2. So let's do the reordering. Grab this guy, bring him over. Grab this guy, bring him over. So we get -2x minus y is 2 plus 2. So that's -2x minus y is 4. Are you good there? Am I going too fast? Everybody see what I'm doing? Let's look back at the answers. Do they have answers? Oh, they don't. So, you know what they're going to do on the multiple choice final?
Okay, you take the second or the first?
Oh my goodness. I was doing number 14 and not realizing it. Yeah, I mean, I did the work that 14 asked to do.
All we had to do was find the slope.
All we had to do was find the slope. Yeah. But it's good. We did basically what 14 requires. Yeah, yeah, the answer is just the -2. So I messed up. Yeah, the answer is just the -2. It's not all that other stuff. Sorry. Yeah, I didn't read the question. I just assumed. I just saw these and didn't read. Yeah, -2. Yeah. So I did what we basically have to do on 14. So you do have to do all that on 14. So don't do 14. But wait, is 14 multiple choice though? Here, let me.
Was find the equation or what was?
So yeah, 14 is all this stuff I just did. Let me mention one thing, because I don't want you to get messed up on the final. If you have this answer, what if like one of the options has 2x plus y is -4? Is that the same? Should you grab that option or not? Yes. Do you realize that? And that's what they're going to do, because they don't like negatives in the front. I just grabbed these off the publisher's website, these questions. They don't like negatives in the front. There's really nothing wrong with it. This is a fine answer, really. But they don't like it that way, so what they'll do is they'll multiply through by -1. Do you realize that whenever you have an answer, an equation, hear me on this, I'm not saying any old thing, but anything that's an equation, anything with an equal sign, left side, right side, is your mind kind of thinking of algebra as two different camps, equations and non-equations. Things with equal signs, things without them. Those are two different worlds, and we need to treat them differently. Things that have equal signs, you have two sides, don't you? So in those cases, you're allowed to do anything you want, as long as you do it to both sides. I can multiply by 1,000,000 if I want to, right? Because they're equal. If you treat them the same, you're going to still be equal. Multiply them both by 1,000,000, going to still be equal, right? Whereas normally we can't do that if there's not an equal sign. You can't be multiplying by 1,000,000 or anything. You change it. But if you have an equal sign, the two things are equal. You can do anything you want as long as you do it to both of them. they'll still be equal afterwards, right? Get the logic of an equation? So that means they'll multiply through by -1. Both sides. So that's okay, because they're equal. You treat them the same, they'll still be equal. So they'll multiply through by -1, -1, -1. That'll make these changes happen.
And that's, that you tell us, if we saw the ends were minus 2x minus y equal 4, or we saw 2x plus y plus equal, so it's the same.
Either one, they're the same. Grab either one. Yep. Both are good, both are right, both are the same. They just look different. Is that good? I don't want you to be fooled by that, because I notice they do that a lot in those answers. I don't want you to do all that good work, get to here, and not realize that's the same thing. That good? So, that was all completely wrong, but really it's what you need to do on ones like that. So 2x plus 3y. So this one, on the multiple choice test, you would see a bunch of shading on all the graphs. So you would know, oh yeah, it's one of those I got to shade. So see what you can do. What do you do first whenever you want to graph? Y alone. We good? So what do we do first? Y alone. Grab this 2x. Jump it over. 3y minus 2x plus 6. Last step to get y alone. Divide by 3. So y less than or equal to minus 2/3 x plus 2, huh? 6 divided by 3 is 2. So now let's graph the thing. Where do we start? Start at 2. Where do we go from there? Rise over run, you go down 2 over 3. 1, 2, 3. So there it is. Down 2 over 3. Connect the dots. We good to there?
Mr. Aaron, you just do the trick on that equation.
What's that?
You just went straight, dividing everything by 3, and you get the answer right away.
Right.
You don't go like we go back and forth, you just boom. Did the trick right there.
Does that make sense? Is that good so far? Now we have to do
No, it's
shading.
good.
Which side do we shade? Yeah, it's always by this last y. Right there. Y is less. Less. Lesser is below. Shade below. And there we go. Is that good?
And it's a solid bar.
Number 16. See what you remember about powers. Let me make that a little bigger for you. So number 16. A to the minus 5, b to the 2. A to the minus 5, b to the 2. All to the negative 3. All right, so what did what did powers outside parentheses do? This might be a good one to write on your sheet of notes. Powers outside parentheses multiply powers inside parentheses, huh? Powers outside parentheses multiply powers inside parentheses. So that negative 3, boom, boom, like that. It's going to multiply those two. So what are we going to get? We're going to get a to the positive 15, b to the minus 6. Is that good so far? Remember that? So powers outside. So here's a note I would put, if it was my final exam coming on Tuesday, I would put that on my study sheet. Powers outside parentheses multiply powers inside parentheses. And now, or you can just put this whole example if you want. Got a whole sheet. Put, problems that are particularly difficult for you, put them on the sheet, the whole thing. And so now, can we stop right there, or is there more?
More.
Yeah. What do we do? Why can't we stop right there? What's the problem with it? Negative. Yeah, remember we never leave negative powers? They're negative. They're unhappy. They're not happy at their job. So what's going to happen? That negative power is going to dive down. It's going to dive down. So a to the 15th, the negative power, whoops, it's not an a. It's b the power becomes positive. And there we go. Is that good? It all coming back? You remembering that? We got 15. All right, try that one. Again, you can't leave negative powers when all is said and done. Okay, so negative powers are unhappy. So this guy's going up. This guy's going up. This guy's going down, huh? The rest are staying put. So 2a and b to the fourth stay put. The other ones jump.
Yeah.
So 2 to the plus 1, a to the plus 7,
Yeah.
b to the plus 1. Is that, I didn't write that too neatly here. Make that a little neater. 2 to the plus 1. Does everybody see what happened there? This guy went up, this guy went up, this guy went down, huh? So everybody see? So there's the ones that were already in place, the 2a and b to the fourth, and the ones that jumped. These two went up, this guy went down. Good so far? And now, powers that are side by side add. So this has an invisible 1 power on it, huh? So, well, this is just 2 times 2. 4. And this is A1, A7, so it's A to the 8th. This is B4, B1, so it's B to the 5th. There it is. Yeah.
The 2 plus 2, the powers, they don't have?
They do. What is 2 to the 2? Yeah. So they're going to have it do it 4. It'd be multiple choice, but they would have it as 4.
If I get kind of confused, like
Is that confusing with the A and the B? Do you see what's happening there? That's because they're just numbers. If they're just numbers, whereas A's and B's are letters, so they can't you can't multiply A times A or B times B. They just combine. 1 and 7 is 8, 4 and 1 is 5. But the numbers, 2 times 2 is 4.
Well, yeah, 2 times 2 is 4. Oh, they don't add?
I was canceling this one.
Okay, so notice what's adding. Not the bases,
What's the
but
cancel?
the powers. Right? Powers are adding, huh? So they did add. 1 and 1 is 2.
Oh, that's true.
And what is 2 squared? 2 times 2, 4. Yeah. Other questions on that? That makes sense?
When I seen it first, I cancel like B4 minus B1, and then I leave B3 in the bottom.
No. Okay, here's the mistake of that. It's a good question. If that was b to the regular one, it's not, it's negative. Over b to the 4. Yeah, you could cancel and that'd be b to the third. If that was regular one, if it was happy, it would stay there and camp, but it's minus 1. So it's not staying there, it's coming down.
Oh, okay.
Makes sense? Because it's negative.
Oh.
If that was positive 1, that'd be exactly right. You cancel those out. But negative guys are not staying. So he doesn't stay.
And that way, when it's like a plus, you only need it in one side of the, like, you cannot have it on both sides. So you have it on the bottom or on the top, right? When simplifying, you know what I'm saying? When you simplify the division, let's say the B was plus, an example, the B was plus, and the B was plus on the bottom.
Yeah, like b to the second over b to the seventh.
Right,
Right, you would subtract them. Only one B. Yeah, and wherever the bigger one is, that'd be where it ends up. It'd end up on the bottom as b to the 5th. You're right. Yeah, that's true. Yeah, all right. Try that one. They want you to divide. So, do you remember what you do on that when you make up 3 separate fractions? Separate them into 3 fractions.
Yeah, you need to keep the X on the bottom because you don't a like term on the top.
I'm going to run out of room here.
Or what they... Yeah, the cheaper one.
Water.
Even the cheap one at Starbucks is impressive.
It's like $5.
I agree.
Whip on it.
A good translation.
Friend of mine is like, oh, I want to make money, and then put a Starbucks. And you have to stop buying expensive coffee. You want to make
I
money.
know it. I feel that way too.
Yeah, it's a waste of money.
I think so too. I wouldn't pay
It's
$4 or
good.
$5. My daughters feel the same way. They just love it.
No,
But
no,
Coffee, yeah.
$1.
I just bought one this morning.
might be worth 50 cents or $1,
50
but
cents,
you know.
50 cents.
All right. Anyway, so we divide by 5x squared, all three of those, right? So and then now, how does this work? So the out front numbers divide, powers subtract, huh? 5 into minus 20, minus 4, subtract the powers, x to the 4th. Okay, good. 5 into 25, subtract the powers, x to the 1, or just x. So far, so good. Last one, 5 into 35, 7 times. The 7's on the top, the x squared stays on the bottom. And there we go. There is our answer. Does that make sense what happened there? Out front numbers divided, powers subtracted, didn't they? Wherever the bigger number is, that's where it ends up, right? So if the bigger power's on the top, the 6 minus 2, the 4 ends on the top. Over here, the bigger power's on the bottom. And the bigger number, in the last fraction, the bigger number, the 35 was on the top. So 5 goes from 35 to 7. The 7 ended up on the top. With power on the bottom, because that's where the bigger stuff was. Not bigger number on the top, bigger power on the bottom.
Where do you have this?
Right? That makes sense? On that? Alfred?
You wouldn't put the X squared over everything? I mean, under everything?
Good question. They like to sucker you on that one, don't they? They always put that as option. No. Yeah, the x squared is just because it's gone here. It's not under that guy anymore, and it's gone in the middle. It did its subtraction thing. That's how we got the 4. And it did its subtraction, 3 minus 2. That's how we got the 1. So it's already done its dividing. We can't also put it back. That'd be using it double. Does that make sense?
Yeah.
It already did its job in subtracting. Yeah, good question. They always put that answer, don't they? They always do the bar all the way across. They put that as one of the options. The publishers like to do that. They're trying to trick you. Don't let them. All right, let's try the factor. They want you to factor. Factor. Okay, so 4 parentheses. Then you just divide them all by 4, huh? Divide by 4, divide by 4, divide by 4.
That's it.
X squared plus 13x minus, is it 14? Good to there?
Oh, that was good.
And now what do we do with the 3 terms? Bow tie them.
4 times.
Can you bow tie the 3 down and leave the 4 in the front there? And now bow tie what's left.
It's minus 14 over 13.
So we'll do the bow tie thing. X and X. What multiplies to be minus 14 adds to be plus 13. What times what is 14? 1 and 14, right? How do the signs go? Sign on the bottom? Bigger. Plus 14 minus 1. Those multiply to be negative 14, add to be 13. So x minus 1, so 4. X minus 1. X plus 14. And that's it. Was that good? You remember that? That's fresh in your mind, right? We just had a test on that. So that stuff's pretty good.